Hi, this is Bill Foote, and now we're going to take our model in this episode from paper and pencil to Vensim, but now we're going to take it from paper and pencil directly to R. What you see here is RStudio. The assumption, of course, is that you've loaded R in and that you have certain packages. The one package you do need, you actually don't need this package if you load the tidyverse. And the loading of the tidyverse would be done like this: install.packages. And this needs quotes. Tidyverse. Okay. And it's got to have all sorts of updating. I'm not going to restart this, but it's in use and will not be reinstalled. Very good. It knows what it's doing. What we're going to do here is fairly straightforward. But we're going to be building a model very similar to this. And this is again courtesy of Fair Dr. Professor Richard McElreath over in Max Planck Institute for Evolutionary Anthropology, Leipzig. He has probably, again, one of the best books I've ever seen on statistics, and it's called Statistical Rethinking Statistics, let's put it that way. And that's out of CRC, but I've already done that. So I have here a R script, and what I really want to do today is create a new file called a markdown file. And I want to just put that together because now I can write, instead of comments, I can actually write English. I'm going to give it a title, don't worry about that. Use HTML for the moment. Here's a new untitled one. We're going to call this Loose Co meets Wolf Co. And Bill Foote is the author. Notice it's putting a system date here and tick marks. This area between the three, the set of three, and it can only be three. It's called the YAML. Yet another markup language, okay? YAML. Yak used to be yet another C compiler. And what this does, and you can read about markdown languages and markup languages, but this is a header. I did this. It's a header of much bigger points. If I did this, much smaller points, and all of this is in my R notice and in my readings. And it gives you a template and shows you a bunch of things. We're not going to use any of these things. Now, these tick marks with the curly brackets define what language is going to be executed inside of this code chunk. Yes, it's called a chunk, and it's a code chunk, and there it is. And what we're going to be able to do is output this. I'm going to do something called knit, but in order to do that, technically you will have needed to have done this, our markdown. See, I already have it there, which means you have to otherwise install it. And that will take care of everything. Now, I'm not going to go ahead and do that because that install will take a few minutes. That we really don't have to do anything here. But notice it's always between these tick marks. Okay. And in fact, I can set up an R chunk very easily just by going to the bottom here and going to the tilde. It's next to the 1 is a tick mark. It automatically knows it. And I don't have to do all sorts of things in here. I could give it a label test, for example. Echo means it won't, when you print it out, when echo equals false, whatever's in here won't print out. Okay, things like that can be done. Or you can just do this. But you have to put the next 3 tick marks in to have the chunk. So the first thing we're going to do is we're going to pull in the tidyverse library, which means you need to have installed it. And that's all we need from the library point of view. And usually we chunk this up into, you know, here's an introduction. Let me introduce you to Monty Python. Oh, introduction. Moose meets wolf. They interact. We will watch that interaction across 10,000 runs. That is meetings. Okay, I'm just being goofy here. Now, the point of this whole thing is that you put in your comments here as much as possible. And here I'm just loading in the tidyverse. And the next thing I'm going to do in the build here we're shuffling papers, is I want to build a function that does a simulation. When I call it, it'll do the simulation. A simulation function. You can get a little bit more creative than that. Again, the tick marks. And functions are great. They're not hard to do. But right now we're just walking through. We're not pretending we know what we're doing. So we're just using a function that was already built. And it's going to be sim_wolf_moose. Yes. Sim plus the action is called sim. Who are the main players? Moose. Got to be underscore. And now, if you do the alt hyphen, this is what happens. And that's an assignment operator. Anything to the right is assigned to this object called sim_wolf_moose. That's how pretty much everything operates in R. And we're going to make a function. It's going to have 1, 2, 3, 4 items in it. The first one is number of steps, very similar to the model setup itself. Initial, and you can already see it knows initial WM here somewhere. Don't worry about that yet. Initial values, it'll be 4 and 30, I believe, right? 4 wolves, 30 moose. We're also going to need a parameter vector. The parameter vector we're going to call gamma. And there's 4 parameters. I'm just going to show you how to set that up. And the time step itself, so we have the number of steps, but the size of the time step will be dt after the calculus equals 0.002. Now, I'm following very, very closely what McElreath does, okay? Because I want to test my model against is and at least start from there. And that is very typical. And now notice you put in curlies, and when you do that, there we go. There we go. You make up it. Okay. The function is defined in terms of these curly braces. And first thing we're going to define are, because this is a spoke function, W is assigned to something called rep or repeat. And we're just kind of making a, okay, NA, we're just making a place for depositing W's as we go through a gazillion meetings, simulated meetings, mind you, between the wolf and the moose, right? And this one is going to be n steps long. It knows it. Notice it's very context sensitive. And this is what is called an integrated development environment, an IDE. Okay, you don't have to put anything here. And you do an M for the moose, alt hyphen, REP, same idea. You're just creating a container. Oops, not plus. And there we go. So we did that. Now we're going to do the initial, very first, that's the first W. And we know it's going to be 4, but it's going to come out of initial. Okay. And the initial is going to be initial 1. That means there's going to be 2 components to initial. Initial 1. And you can guess that M1, the very first one of those, oops, sorry about that, okay, is initial, guessed it, you guessed it, you guessed it, 2. Very good. Okay, so now we've got our initial conditions, and now we're going to do something called a for loop. For. Now, the for loop just is an instruction to do something, in this case, for I in 2 to n steps, okay? So 2 to n steps is, okay, I in, and now this is special to R, for I in, so you can imagine that if we have 10,000 n steps, okay, the first one is the one, that's I equals 1, and I equals 2, we're going to start with 2, right, because we already have 1. And then the colon is, it's the from to operator, and steps. There we go. Now we define that, and we're going to put a curly brace around this as well. Now that's, see how it blocks so nicely? It loves white space, Python. And so we just copy our equations in here. Instead of t, well, we could do t here. Why not? For t, there we go. M e plus 1. If you read the equation, right here somewhere, don't I? Here's that. There it is. T plus 1, mt, and then a plus and a minus. We've already done this. We've written these equations inside of Vensim. All we're doing is just copying them, but we're rearranging like a composer here. Okay. Again, assignment. And it's going to depend upon whatever was an M P minus 1. Now, if t equals 2, t minus 1 will equal 1, and this thing will be able to work because we defined 1 already. And then we're going to add something, and we're going to do we're going to save, and we can do an unpacking routine. Okay, gamma 1 1 times m t minus 1. Okay, we're just following the equations. That's the birth process, minus gamma 2. And we're going to have to do something else here, actually. Matter of fact, I'm going to put a parentheses here, because you're going to watch what happens here. It's going to be very, very interesting. 2. That will be our switching process. And remember, that was times m t minus 1. And here's the interaction term, times w t minus 1. Very cool, huh? Close the parentheses, and you have to multiply this whole thing by dt, by the time step. And this is how this thing inches along. The dt is a fraction, a very small fraction. Okay, now we do the same thing for w. W t minus 1 plus, now there's things going in, and the thing going in is pretty complicated, actually. The thing going in is going to be gamma 3. The thing going out is gamma 4. Okay, so gamma 3 and I'm going to use our approach where I'm going very off of what McElreath does. Gamma 2. Well, notice, just notice that when I put this in, it automatically put the right parentheses in. So anyways, that's gamma 2, the switching rate. Now we could do better than this, and we can improve this, and I'll ask you to do that. So this is going to be a multiplication of both m t minus 1 times w. And see, I love it when it does that. And I love it because it makes it, you don't tend to forget the thing. Okay, good. Okay, so that's a long thing. I'm going to do this. And this, just so that you can make a nice one. Okay. And make sure that you have all of these asterisks. These are the multiplications. Now that's going in. Going out is just gamma 4, which is the switching rate. Why? Because I defined it that way in my mind. I didn't document it, did I? Okay, and that's something that we would do up here, because gamma is easy to deal with, especially later on. Okay, and we're doing very large-scale simulations. Okay. And all this times dt. I don't need that. I need that one. There we go. So this is the stuff that changes with time. And I didn't do this right. If this is empty. Okay, now I got it right. And why do I have it right? Well, t minus 1, that's going to be 1 when t is equal to 2. Okay, so now it's correct. I had a plus 1 because I was not thinking about this properly. So I got my equations in there, our equations. Remember, these are our equations. And the next step is to go like this. And this is what I call good practice. The very last thing you put here can be returned. Okay, the very last thing. But I like to tell everybody that we're returning it. Why not? And I'm returning something called a tibble, which is a data frame, a subset of data frames inside of R, but you have to use the tidyverse to get it. Okay, yes, I know, kind of silly, right? And I'm going to define this, and this is literally going to define the two columns of this. W equals W, okay, we call it W equals W, comma, and this is where we use equal signs. M equals M, and you see it's already, it knows that I have two parentheses. See, it highlights it. That's pretty important. And I think I'm done. Okay, so I have my function. And we're going to run this function. It's going to be great fun when we do so. But let me see if there's any mistakes here. Nope, looks good. Looks good. Look what happens over here on the console. There's one. There's the other. And notice the pluses. It has been defined. I now have something called simwolf. Okay, I have a function now. And it's very exciting that I have the function. I'm going to save this RMD file I'm going to probably put it in my models or my notes. I'm not sure. Yikes. Okay, I'm just going to put it here. Wolf eats moose. It's going to save it as a special file extension, RMD. Okay, good. Now, that's pretty cool. Now we're going to go down and, having defined a function, we proceed to make some data for the function, and hopefully it'll work. So we might have a data section, and herein we set out the data. Okay, it's being silly, but you will of course be silly too, because it's already late in the day and we're doing programming. Oh my God, there we go. Make this code chunk. And I'm going to be defining, I need to define gamma and initial basically. So gamma is going to concatenate 4 items. Gamma, alt that, C for concatenate, open it up, there we go with the parentheses, And the first one is going to be 0.50. The next one is going to be 0.05. And the next one is going to also be 0.5. We may change this. And finally, the last one is 0.5. A lot of wolves get killed off. That's what's happening here. A lot of that customer base gets gone. Initial WM, I'm going to call it that, is going to be a concatenation of two items, because we have two of them. One is 4, one is 30. Again, what I'm trying to do is I'm trying to calibrate to his model, Richard's model, but I did something different here. I put these all together. Gamma 2 is whatever it is, 5%, right? And this one is going, we may have to play with this a little bit in order to get what we want. Trying to be a little bit clever. And these are like transition sentences always. Next, we simulate. Now, I'm just chunking out the workflow, if you will. And then we simulate until morale improves. Improves. There we go. Here in the simulation. Sorry, just being, again, a little quirky here. And this is going to be very straightforward. Now, if you're familiar with Jupyter Notebooks, it's the same idea. I love Jupyter Notebooks. I do APL2 in Jupyter Notebooks now. I got a kernel for it. It's really nice. My go-to language. This is good. All right. We have gamma. We have initial. We're going to call this thing, we're going to deposit our simulation, this thing, into something called Z. Zebra, Zulu, Sim. I think it's called Wolf Moose. Is that what we call it up here? No, it's Wolf Moose. There it is. It knows it. Okay, now remember what was in it? Well, it tells you n steps, initial, and gamma. Okay, we need to define n steps. Hmm, 10,000. Okay, 1e to the 4. 1e4 would do the same thing. Gamma, we already know what gamma is. And initial, see, it's contextual. I love this. And we don't, that because we've already assigned a value to dt as 0.002. We don't need to put it in here again. Okay, it will know to do this. Now, I don't know if this is going to work. Let's see what happens. We'll find out if we made any mistakes. Nope. Let's look briefly at what's there. We can do structure of Z, of Z, and you see 10,000, 1 to 10,000. There's 2 columns coming okay, good. A W and an M, and a lot of NAs. Wait, have problems. That's not going to do anything for us. So we have to fix some of those problems. Now, it's interesting that when we did the Vensim, there are all sorts of things going on inside of it. And what one of those things is changing these gamma numbers tremendously will affect things tremendously. No doubt about it. If I go back to the Vensim model, did an improved model here somewhere. There we go. This is what he gets. And how did I do this? I went to model settings. There it goes. And I put in a much finer rate in 0625. Still 0 to 24 months, but much finer time steps. And what that did is it smoothed out an awful lot of the noise. Okay. And so, okay, fine, good. Okay, so, and notice I got a nice, that this happens over here is good. All right, so what, I'm going to get something like this with McElreath's model too. Okay, that's where I'm going to go. And here's the rates and so on. Now I don't remember what those rates were that made this work so well. 0.5, there we go. I know where the problem is. Right here. This needs to be 0.5. Now, here's the problem. I better put a note in here somewhere. This is C of moose acquisition. Moose switching. Wolf acquisition. And wolf, and that's a rate actually, but just bear with me for a sec here. And wolf switching. Okay, just to make sure we have that in there. You already see what happens when you start not telling yourself what's around. So it's 50-50, 50 and 0.05. I think that's going to work. I need to save this and that. And then we try the simulation again. It simulated pretty quickly. And do the structure to see if anything happened. Yes. No. Don't know. Doesn't look like anything happened. Okay. If I do a head of Z, you see it's all NAs. So I know I have a problem. Okay. I know I have a problem. And you know what the problem is? I put gammas in first and initial in second. Okay. So this is called shooting trouble. How do I know that? Well, if I did this, see, it says N steps. I did that right. Initial, gamma, I messed up. Okay. And here we go. This ought to work. Yes, lots of numbers. Yeah, 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 that works. That works. Very good. Happy to be of service, yes. And the head will give you the first few of these. And the tail will give you the last few of these Z's. There we go. So that's kind of interesting. Going up and going down. There's going to be a lot of very good stuff to watch here. Okay, and then having figured out how to use the function properly, we have a simulation. Okay, good. And finally, visualize, plot it. Okay, and plotting it will get us this. Now, we're going to use something called ggplot. We can set this up in a lot of different ways, but we're gonna basically make a plot that's going to look a little bit like the other thing. But I'm going to use a package called Plotly with this, so that we can do some interactive work with the interactive model of wolves. Now, we've got to install Plotly, and because we're saving this in HTML, this thing will plot out. But what will happen is we'll put the mouse over it. We can see stuff. Okay, that's going to be important. We can also brush. And that's an interesting thing. So ggplot is how we start it. And this is the way you got to use pluses. The grammar of graphics works. And I'm just taking a kind of a page out of geom_line. So now ggplot just sets up a canvas. Okay, it's a blank canvas. In geom_line, what do I use? Yeah, I think I need to put Z in here. Z needs to go in there. Nope, I don't need to do it for this, but it's good. It would prefer that I did, by the way. You'll see what comes up. I've forgotten already what the problem will be. And then something called an aesthetic, AES short for, an aesthetic mapping. Okay. And we have X. I'm just going to really rough and ready this. 1 to n steps. It will know n steps. It's 10,000. I don't have to do 1 to 10,000. 1 to n steps will do it. And Y, the Y-axis, will be the first one, Z. And this is how I access it. Using that. Using that $sign as the operator to access that column. So that's one line. Plus another line AES X equals 1 to 1 steps. Now you can shorten this up a bit, but I just want to be longhand here. Y equals the simulation column. No, lowercase Bill. There we go. The column M for the Mises. Okay, and we can put labels on and all sorts of other things here, but I just want to get us to the point of seeing a graph. Now, we can just do P here. And it didn't like something. and steps not found. That's right, I didn't define it. And you see, now I'm going to go back up here, and I think I should define it, don't you? Yeah, maybe we can define it here. That's properly in the simulation piece. There we go. So I don't have to hard code it in. So if I do this, yeah, there we go. And it worked. Okay, now what I was doing was I was just putting the cursor there and doing Control Enter to get all of that. And now I'm going to try this plot again. I'm going to do that in a second. There it is. It looks almost like the one in Vincent. Very, very close. Okay, now we can format this, put labels in, do all sorts of interesting things. I don't know which one is which. Okay, it goes on and on. And you can actually add that. That would be your exercise. Add that. And it's inside of, well, you can look up ggplot too. Definitely. It's also inside of Jim Duggan's book. Okay. But what if I wanted to make this a little bit more interactive? ggplotly of P. Notice it's trying to do something. There it goes. And now look what happens. See? That's the moose, and this is the wolf. And it makes sense. You have to have moose around for the wolf to eat. Okay, that's the biological model. You have to have susceptible people around so that they can get infected. Okay, that's the infection model. Okay, you have to have people working, in order to have somebody taking advantage of them. That's the Galbraith state in Mother Jones. And notice we have peaks and valleys. This is a periodic model. It's oscillating, and it's oscillating exactly the way I would have expected it. I expect this to be bigger than this, and this to come before, this peak to come before this peak. I expect that. It makes sense to me. Does it make sense to you? Okay. And so Plotly allows us to do this when you can't do this with a PDF file. Make sure you have an extra space. All is in order. Okay, everything is in order. And we can do this too. Two-part, all at once. Okay, it's all here. And then the last piece is interpret. More moose base and wolf base. It's customer base. Moose peaks before wolf peaks. It's going to be my main things immediately, and then I'm going to explain how and why and what. And we can also pull some other interesting stats out of this. There we go. Now, I know all of this should be working. I'm going to do something called knit. May or may not work on your machine. It tends to. And you can see stuff going on in the background there, unnamed chunks. Oh, and what I'm seeing looks very good. Got all sorts of stuff that you don't care about. We got our first wolf call. I got to fix that. Wolf makes wolf. Okay. I have something that's better than a simple script now. And watch, because I can look just at this, for example. Watch this. Whoa, that's called a brush. I can focus in on this area. Okay, and you can see that with that tool tip as it moves with the crosshair. I had better put in everything here. You know, we happen to know what Z is and W and what end steps are, and yeah, it's actually both of these are here, not just W. It's only picking up the first one. Yeah, we need some work there. Honestly, I'm ecstatic the thing worked. I don't know how to get this back. I think you have to zoom in, zoom out. Oh, we have that. That's lovely. And we're back to business with the auto scale. Okay, I hope this was fun. It was fun for me. We're going to do this a lot, and I urge you to play with this. Now go back to Jim Duggan's book and pull some more interesting stuff out. The other thing that needs to be done here, after this, we usually put something called session info. We could do that later, but to do. I could do one. Yeah, be a friend to yourself and define gamma. Okay. What else can we do? We can put labels on the graph, even a legend. Okay. Well, those are at least what we're going to do. So I'm going to leave you with this. I'm going to save this, and we should be in good shape. Thanks very much. I got people calling and things to do, and we're all set. Take care. Thank you for your kind attention. There we go. That's my signal to wrap this up. What did we do here? Quite a bit. My gosh, we actually did some arithmetic. This is basically arithmetic done 10,000 times over. And we did it. Need to fix this, don't I? Wolfco. We did it in an interactive way. So I'm going to leave it with that. Thank you very much for your kind attention. You are in the deep end of the pool, and you're treading beautifully. So we will work on this for the rest of the week, and on the Saturday live session, we will embellish it. We will use it to begin to learn more about interactions, okay, which is going to be really the key to this whole course. Key to system dynamics in general, key to understanding behavior is really understanding the interactions. We will leave you with that. Remember to keep encouraging each other. Do so daily while it's still today. Put your stuff up on a share. Write emails to each other. Help each other. Okay. Nobody should do this by themselves. I know I don't. I reach out to all sorts of people. That's where I got this model. This model will be on the site along with the link to the YouTube video. And with that, I'll leave you to it. Take care and have a great time. Enjoy your success here.